While companies market AI as an almost magical black box, we do know how LLM's core components work. This video will explore a key component behind large language models, tokenization. In previous videos, you may have heard the term tokens. Tokens are essentially units of data in a form the LLM can ingest and compute in their algorithm. Your words, in natural language, are transformed into tokens through a process called tokenization. One token is around the equivalent to 4 characters in a word, so 75 words would be around 100 tokens. Remember those layers I had talked about previously? Your words in the input layer turn into tokens in the hidden layers before being translated back into natural language in the output layer. Please note that these tokens are not a one-to-one translation of any language. I have at the bottom of this slide an example that I created through ChatGPT. They have on their website a way to see what the tokens would look like for your input in comparison to natural language. In this example, I wrote, "The colonization of Hawaii involved early European contact that introduced devastating diseases and foreign influence, followed by American missionary and business interests that systematically dismantled the Hawaiian kingdom and culminated in the illegal 1893 overthrow of the monarchy and the 1898 annexation by the United States." That's a long sentence with 329 characters, and it turns into 56 tokens. When it goes into the hidden layer, it is breaking down those words into around those 4 characters to become tokens. So colonization does not actually look like colonization in the hidden layers. It's actually been split up into 2 separate data points, where it is colon and ization, as you can see from the different color blocks that denote where the token starts. Same with Hawaii. With the okina included, it makes it so that it is 2 separate words or 2 separate data points. You can see that as well with dismantled or culminated. And I also want people to notice that it does this every time with dates or numbers. 1893 and 1898 are both not the whole complete year. It does 189, and then the next word is 3 or 8. It is not actually a perfect understanding of the English language. The English language has turned into a numerical data point that the LLM will be able to use statistical probability with. So what does that actually look like? What do your words look like as tokens? Tokens look like this in actuality. All of those words that you put into ChatGPT or Gemini are turned into these numbered data points. That paragraph that I have at the top of the slide turns into the tokens in the bottom image. When we had those split words like culminated, they were made into 2 separate numerical inputs for the tokens. And I think that this is just a really clear way of seeing how these large language models are not actually doing any analysis or connections of things through the English language. It's all based on these numerical inputs with assigned meaning. Those tokens are weighted by probability and statistics from its training data to generate an answer. If you still have any questions, WCC Library is here to help. Feel free to reach out to us by email, phone call, text, or chatting online. A librarian will be available to chat with you Monday through Friday from 8 a.m. to 4 p.m.